My name is Imran. I have done my engineering BTech from JNTU 2011 pass out. After that, I have joined Vasavi Power Plants in Hyderabad as a control room operator. 250 megawatts power plant CCPP command cycle power plant for 3 years. I have worked there, and after that, I have joined Doosan Heavy Industries as an operator for Puraya Power Plant located in Puraya. Client was SEC and project was 390 megawatts with 3 GT, 1 STG per 1 block, total 5 blocks. GT was fuel type and natural gas and oil, and 600 degrees centigrade. Exhaust pressure was 418 degrees centigrade and fuel consumption was 10 kgs per second. Exhaust emissions was N2 70%, O2 30% and AR 0.8%, H2O 10%, CO2 4%, and grid frequency was 660 Hz. Generator was 198 megawatts and 118.0 kV. Power factor was 0.5 and STG was 260 megawatts. And manufacturer was Doosan and rated speed at 360 rpm, 3600 rpm. Type was triple pressure HP, LP and IP. HP inlet 126 bar and 565 centigrade and for 156 kgs per second. IP inlet was 36 bars 560 degrees centigrade 175 kgs per second, and LP inlet was 8 bar 300 degrees centigrade 200 kgs per second flow. And generator type was D11 type with 355 MVA and 18 kV. It is a hydrogen type cooled. HRSG was vertical type and triple pressure, and manufacturer was Doosan. Consists of HP, IP and LP with D-rated top of LP with DD damper and Gulton damper and stack damper. Closing speed of 60 seconds and emergency closing speed of 20 seconds. HRSG exhaust temperature was 100 degrees with 3 BFP pumps. Manufacturer was Hyundai and speed was 3150 rpm intake. And intake was 8 bar from LP and HP and IP. Exhaust HP was up to 60 bars and 20 bar. 3 drums of HP, IP and LP were getting the water from CEP. And BOP area consists of a CW pump, surface type, cooling condenser with a water box, and CVP and water box vacuum pump, and lube oil system with a hydraulic oil pump, seal oil pump and lube oil pump and emergency oil pump. And a hydrogen system for cooling generation with purity of 99%, hydrogen purity of 99% and 60 psi is maintained for the cooling purpose of generator. And MSF is for dimming water generation. For the startup process, as an operator, my job was to ensure that the plant was running at a normal operation. I used to monitor different parameters and take the readings on the log sheets for daily job routines. There to check the CEP pump for weekly routines. There to check the standby pump and running and changeovers of CECW and ACW pumps and heat exchangers and lube oil pumps and hydraulic oil pump and CEP and changeover and ESDG checks, CTCS system and TCS systems start in 1 week rotationally. And monthly checks where oil change in a standby pump and grease and alignment checks and vibration checks for the motors and lube oil checks for the CFM checks. And during the short shutdowns, the opening of condenser manholes and checking the pits and as well as cleaning up the sumps and strainers, cleaning up the CEP strainer. And with long shutdowns, HRSG drums were cleaned and filled up with nitrogen and lined up with chemicals to prevent from corrosion. And beyond this, if any punch list is produced by the client, we used to solve that issues during the shutdown time or else during the long shutdown times. And during pre-commissioning, we used to produce during the pre-commissioning state, we used to check all the materials available and drawings available and installed according to that. And in commissioning state, we used to follow up the cold and hot loop checks, RFI checks, and for the startup process, we are having the different types of startup and shutdowns. If the shutdown is less than for 8 hours, and HRSG and ST blow temperature should be checked, and then it is a hot startup. It can be completed within 100 minutes. And if the shutdown is more than 8 hours to 48 hours, it is a warm startup, and it can be completed within 160 minutes. And if the shutdown is 48 hours and above, the shutdown is 300